can maybe cover the management part, and then I'll hand it over to Sunny for the full picture. On the network slicing management, in terms of what's there in the future, I think the future is extremely interesting in terms of network slice optimization. And that's where we will introduce a fourth technology. So you mentioned 5G, you mentioned edge computing, you mentioned slicing. We'll introduce machine learning. So machine learning will be able to see the usage and the utilization of the slice and in real time make optimizations. So that's the next big thing from our standpoint, is how to optimize these slices, because all the bread and butter stuff has been done. Creating slices, terminating them, configuring them, all done. So that's what we are looking forward to. We are also looking forward to actually getting this into many, many customers. So at least from my standpoint, we are a little early. We are maybe not as far advanced as Kaloom. So we have trials going on, hopefully going into production by early next year. But next year, we hope that slicing will proliferate. So those are the two things I'm looking forward to. Good question. So in theory, it should be plug and play, right? So if you follow the 3GPP standards for 5G core, if you follow O-RAN standards for your RAN, for slicing, if you follow similar standards, 3GPP and O-RAN, and on the transport side, IETF, it should be plug and play. But I can tell you, there is no such thing as plug and play in real life, right? Nobody complies to the standards perfectly. So what you end up having to do is to make adjustments. And from our standpoint, we can make adjustments on either end. Either we can make an adjustment on the network function side. So the 5G core or the RAN can make tweaks to better align to the standards. Or our offering is a platform. So we can definitely make adjustments and adapt to what the network functions offers. So, and you have different standards. For orchestration, it may be Helm charts. For configuration, it may be Yang NetCon for REST APIs. For data collection and analytics, it might be VES, HVVES, and other formats. So that's the generic answer. Maybe more specifically on slicing, there is a component called NSSMF, Network Slice Subnet Management Function. The NSSMF is the one that interfaces between the management stack, network slice management stack, and the network function. So what we are leveraging through Linux Foundation, there are standard NSSMFs for core, RAN, and transport that are standards compliant. If the network function is completely standards compliant, great. If not, we can develop a custom NSSMF. So that's sort of how we adapt to the various different vendors.
Got it.
Actually, on that, if I may add a couple of quick topics, one or two on technology side, and then coming back towards the customer side. As Amar said, things don't work plug and play, but it's not as bad as plug and pray either. Our experience has been, I'll give two examples very, very quickly. Talking about specifically, we provide UPF only. So we work with AMF and SMF provided by vendors, maybe large incumbent vendors or some upstart open. Initially, and we've done with multiple of them, initially, it was a longer time that it was taking with everybody's implementation, though, of 3GPP standard, different unique implementations, if you will. But we've watched over the time, it gets easier and easier. So that's number one. Similar thing on the orchestration side, if you will. We've seen this where when our first customer asked us to do orchestration with one specific tool that they had chosen to take a look at, it took us about 6 weeks to work together and do that. Subsequently, we've done with 3 or 4 vendors, and we got it down to days now, not even weeks. So it does help from that perspective, right? The last 2 notes very quickly, technology side. Look, what we see where it's going from network slicing perspective, look, it's got to scale. It's got to scale at a very, very high level, both from bandwidth perspective. It's got to scale very, very high from a subscriber number perspective. Of course, it has to maintain the latency, But last one that a lot of people forget about, and we talk a lot about SASE and this and that, security is going to be kept in mind 100% as well. When we do it in the hardware, all P4 enabled hardware and fabrics that we use, that kind of brings some amount of security inherent into that. Last note, and I'll definitely last note, if we look at the customers from this perspective, enterprise or service provider, the end game is you've got to be able to offer differentiated services.
Yes.
Differentiated services for which you could charge for if you're a service provider, or differentiated services where you could guarantee certain services to your internal BUs or external customers and what have you. And that to us is, when you put it all together, is the huge benefit to bring the differentiated services of many things that Amar and I discuss over time. I think that's the name of the game, and that's the excitement part, both for the enterprise and service provider customers. That's the end benefit from that perspective.
Sunny captured it perfectly. Ultimately, all this technology has to serve a purpose. And what is that purpose, right? I think you captured it very eloquently. For a service provider, it's to increase the potential revenue. We all know that the average revenue per user, or ARPU, is only going down. So how can we expect the service providers to roll out such a CapEx intensive 5G network? And it's through techniques such as this. Edge computing applications, network slicing, those are the ways they can make more revenue. And when it comes to enterprise, it's not so much about increasing the ARPU per subscriber. That's not the case, but it's cutting OpEx. How do you cut OpEx for your environment? How do you improve your customer satisfaction? How do you roll out new services faster? So I think that's ultimately is the promise of network slicing.